Welcome back, everyone. Today we'll be looking at trigonometry 2, which is cosine rule. We've already started this topic, and remember our aim is to treat bearing and distance. But in our previous classes, we've done the quadrants, first, second, third, and fourth quadrants, and the relationship between the three functions, sine, cosine, and tangent. And we've also done the use of the Pythagoras theorem, which has to do with a right angle or triangle. And we've done sine rule, which is also trigonometry 1. And we've solved questions relating to sine rule. But today we are going to be doing cosine rule, because our aim is to treat bearing and distance, like I said earlier. So how do we use this cosine rule? But before we do that, before we go into questions, I want to give a short proof, which will do everything possible for you to understand. Let's assume we have this. Let's assume we are given a triangle of this kind, this A, and this happens to be, let me say, C, and this is B, and this is an acute angled triangle, meaning all the angles inside are what? Less than 90 degrees. How do we prove that this angle, we can get something like, let me say, C squared equals to A squared plus B squared minus 2AB, 2AB because capital letter what? C, because this is one of the rules for sine. We can also have it as A squared equals to B squared plus C squared minus 2BC because capital letter what? A. But let's focus on the top and see if we can prove it. So we're given this triangle. This was given. Now let's redraw the triangle and put some salient points. So this is my A, this is my B, and this is my C. This becomes small letter C, small letter A, and small letter B. Let me put the B down. So let's bring a perpendicular from B. If I bring a perpendicular, that simply means this should be a right angle, and this equally should be a what? A right what? Angle. And let the line where B meets AB, meets AC rather, be what? D. And let me say, let B be the height, which will be equal to what? H. So I can have from triangle ABD, this triangle here, C, H, A, D, B. And let me take AD as X and DC and what? As what? Y. So this becomes what? X. So from triangle ABD, we can see that C squared, my marker. We can see that C squared is equals to H squared plus X squared. You can take this as equation 1. And also from search for a better marker, please. And also from triangle BCD, which is this. This A, this is H, this is what? Y, B, C, and D. From this triangle here, we can see that A squared this time is equals to what? H squared plus Y squared, because our A is the hypotenuse in this case. Here C was the hypotenuse. So we have this, and we can make H. Let me make H sort of formula here to have H squared to be equals to, if H squared is positive, then this becomes C squared, and this will move to the other side minus what? S squared. So this becomes my equation 1. Let me write it bold, please. C square equal to S square plus H square, because this is the hypotenuse side, so it must equal the square of the adjacent and the opposite side. And making a sort of a formula, I have H square, assume H is here. I'll have what? C square, and S will move over to become minus S whole square. This becomes equation 1. And I've gotten A as my square, which is the right, where the right angle is facing the hypotenuse side, is equal to H square plus what? Y square. And these are gotten by what? Pythagoras theorem, remember. Pythagoras theorem. Also what? Pythagoras. Now, I want to make H square sort of formula also. H is already positive. So I can say what? A square is here. This will move to the other side. A square minus what? Y whole square. This becomes equation what? 2. Now, if you notice, A square is common in the two equations. So therefore, I can simply what? Equate H square to A square and equate C square minus S square to A square minus Y square. So I simply have C square minus S square to be equals to what? A square minus Y square. Since A square equal to what? H square. Now, I can make C square sort of formula, or I have C square to be equal to A square, this is positive, let it come first, plus S square minus Y square. Let me take this as equation what? 3. But if I look in from triangle ABC, which is a complete triangle, you can see that X plus Y is equal to B, because AD plus DC is equals to what? B. So I have S plus Y to be equals to what? B. And I can make my S sort of formula to give me X equal B minus what? Y. I can take this as equation what? 4. If this is my equation 4, I can therefore substitute, SUB substitute please, B minus Y in brackets for X into what? 3. So I'm putting B minus Y for X into 3. So if I'm putting it into 3, I have C square equals to what? C square equals to A square plus the value of X, which is B minus Y. B minus Y, close bracket, square, minus what? Y square. So to save my space, let me expand this. This is B minus Y square, which is equals to B minus Y in bracket B minus Y. B times B is B square. B times minus Y is minus BY. Minus Y times B will give me minus BY. Minus minus is plus. Y times Y is what? Y square. So I have B square minus BY minus BY will give me minus 2BY plus what? Y square. So I'll put this in place of B minus Y square. So I have C square. Since here is positive, I'll just put it the way it is. But if it was negative, all these signs will change. Take note. So I have A square plus B square minus 2BY plus Y square minus Y square, which I have here. So this is the expansion for this. Remember, so I can wipe this. So I have C square to be equals to plus Y square minus Y square. We cancel out to give me what? 0. So I therefore have A square plus B square minus 2BY. Now, we're almost getting it. If you see, we have C square, A square, B square, A square, B square minus 2BY. But we have A here, AB equals what? C. So what do we do next? Because they are not exact yet. So let's focus on this as C. So let's say from triangle BCD, and I like drawing my diagram because it gives a better picture of what we are doing. B, C, D. This is Y, and this is H, and this is what? A, and this is my angle. We can see that cos of C, cos is what? I'm using this angle, so this is my hypotenuse. This angle make it to be what? Opposite. And this become what? Y become adjacent. If you've been following our previous classes, you will understand what we are doing here. So cos C is what? Adjacent over hypotenuse, which is Y over what? A. If I cross multiply, I will have what? A, I will have Y to be equals to A cos capital letter what? C. I can take this as my equation. Let this be equation 4 and let this be equation 5. So we can say substitute in brackets A cos C for what? Y into 4. So if we are doing that, where is my duster? If we are doing that, it's no longer useful. So if we are doing that, we simply have C squared to be equals to A squared plus B squared minus 2B. In place of Y, I'm putting A cos C. So I have bracket A cos capital C. Let me use a square bracket so that it won't confuse anybody. So I therefore have C squared equals to small letter c, please. C squared equal A squared plus B squared minus 2B. B times A is same thing as AB. So let A come first. AB cos capital letter what? C. And with this, our rule has been what? Proved. Also, with this, we can also get the two orders, which are A squared equals to what? B squared plus C squared minus 2BC cos capital letter what? A. Remember, the side here follows the angle that we are going to have here. And also, we've proved that of C and we've done what? A. So let's do that of B. So also we have B squared equals to what? A squared plus C squared minus 2AC cos capital letter what? B. Repeating this process from the very beginning will give you what? This other two. And from this main expression, I can get my cos C. How do I do that? I simply do that by making my cos C the subject of formula. You can see that this is what? These are combined what? Values. Because they are combined by what? Multiplication sign. This 2 times A times B times cos what? C. Cos C must go together as 1. So if I want it to be positive, I'll bring my negative to the other side. Then this become 2. This become 2AB cos capital letter C. This have moved to the other side, so this must come here. A square remain here, B square remain here, and plus C cos become minus C what? Square. Now I'm looking for cos C. I can simply therefore divide through. I can simply divide through by what? 2AB. If I divide through by 2AB, because I'm looking for cos C, or have cos capital letter C all over what? 2AB to be equals to what? A square plus B square minus what? C square all over 2AB. And if I want C to stand alone, which is not common in some textbook, I'll have capital letter C to be equals to cos inverse in brackets A square plus B square minus C square all over what? 2AB. And we have this. And in the same way for those other angles, we can also have angle what? B to be equals to cos inverse of, since B is here, you simply have what? A square plus C square minus, you subtract that of the smaller angle, B square all over 2 times this 2 without the square, 2AC. And that for the third Remember, we are done with our proof. And that of the third, using this as our case study, will give us cos A, which is angle A, to be equals to what? Cos inverse of open bracket. Since we have capital letter C here, we must have minus small letter c square. So we have A square plus B square minus C square all over 2A what? B. So this capital C, capital B, and capital letter what? This A rather. I did see a second. So this should be A. And if that's A, I will have here as B square plus what? C square minus what? A square all over 2BC. And these are the three what? Expressions. B square plus C square minus C square over 2BC. Yeah. So this angle C, angle B, and angle A, these three formulas are used to get your angles when the three sides of a triangle are what's known. And when a side is known, let me say I know the two sides and the included angle, I will simply use what? C square. Included angle meaning I have something like this. This is my A, this is my B, this is my C. You know, this must be my side B. So side B is given, let me say 3. Side, what is it called? Which other side? I've gotten my B. Side A is also given, which is, let me say 4. Now, okay, let me say 5. Now, the included angle was also given, which is this capital C you are seeing here. Let me say 45 degree, just assumption. Okay, let me say 55 degree. We can use this formula C square equals A square plus B square minus 2BC cos capital letter C to solve my side C here, if it's a question. And also take note that if we are to solve this, the sum of two angles like we did in sine rule will also be greater. The sum of two sides must be greater than the what? Third side. Any two sides, the sum of any two sides must be greater than the third side. And also the bigger angle we have, the bigger what? The bigger angle we have, the bigger side. And also, so two ways we can use cosine rule is first, when we have two sides and the included angle. The included angle is the angle formed by the two sides. And also, when we have three sides, we can get the three what? Angles. And sometimes we need a combination of sine and cosine rule to solve what? A triangle what? Problem, which basically is a what? Bearing problem. So this is what we can do for now. Let's do some other examples. Let's do examples to verify these are what? Sine rule. Thank you. So we'll be focusing on cosine rule of an acute of obtuse angle this time. So let's assume we're given triangle CAB that angle CAB is obtuse. Let's have a diagram of this kind. Let's assume this is a diagram. Let's say we have this way, and we have this way. And we have our C here, our B here, and our A here. Remember that A is angle CAB is obtuse, which is angle A is obtuse. If angle A is obtuse, simply means it's greater than what? 90 degree, but less than what? 180 degree. Now, how do we prove that? And we are to prove that A square equal B square plus C square. Take note, plus 2BC cos 180 degree minus what? A. How can we prove this? Now, let's assume this is what we're given. Now, let's assume we take an extension from AB to the right, and we also bring a perpendicular from C downward, and this forms a right angle. We can take this point as D. We can take DC as what? Small letter d, and we can take DA as small letter what? E. Now you can see that this is angle C, so we must have small letter C here. This is angle B, we must have small letter B here. And this is angle A, and we must have small letter what? A here. Now let's start from triangle BCD. From triangle B, C, and D, we have the hypotenuse, which is this side where this right angle is facing, as CB square to be equals to what? Adjacent and what? Opposite and what? Adjacent. And my opposite here is what? Opposite is what? C capital letter D square. And adjacent here is what? DB. Also what? Square. So CB is represented by small letter A. So I have A square. CD is represented as what? Small letter D. D square. And CB is made up of DA plus AC. And DA is what? E. So I'll have E plus AB is what? C. So I have C. Or close bracket what? Square. I can take this as my equation what? 1. And if I focus on the second triangle, the second right angle triangle there, which is from triangle ACD, from triangle ACD, I will have AC square, which is the hypotenuse side, will be equals to the opposite side, which is what? I can say D square, opposite side D square, plus what? Okay, let me write it as it is. The opposite side, which is what? CD again, close bracket square, plus what? Opposite side, so this become adjacent side, which is what? DA, close bracket what? Square. And AC here is what? B. So I have B square equals to CD is D. D square plus DA is what? E. So I have E square. So since I have D square here, I can make D square square root of formula. If I make D square square root of formula, since it's positive, I will assume it's T here. So I'll leave this like this, B square, and I'll move plus E square to the other side, become minus E whole square. I'll take this as equation 2. And I can simply put B square minus E square for what? D square into 1, into equation 1. Take note, or let me put the 1 here. So if I do that from equation 1, I'll have A square to be equals to, in place of this square, I'm putting this, remember. So I'll have B square minus E square plus, I have E plus C, all what? Square. So I have A square to be equals to B square minus E square plus, if I expand E plus C square using binomial theorem, I'll have E square plus 2 times E times C, giving me 2EC plus C what? Square. And I'll have A square to be equals to minus E square can cancel, minus E square can cancel plus E square. And I'll have B square. I can rearrange this to the other side, plus C square plus what? 2EC. Now from this, I can see that from equation, from this triangle ACD again, from triangle ACD, if this angle CAB is obtuse, greater than 90, then this angle here must be what? Less than 90. Why? Sum of angle in a triangle is what? 180. So whatsoever angle is, angle A, angle CAB is, this angle CAD will be equals to 180 degree minus the what? Angle. Take note, because this is a straight line. So if CAB is greater than 90, there's no way CAD will also be greater than 90, because if both are greater than 90, then sum of angle in a straight line is greater than 180, which is what? Wrong. Now, from there, I can have the cos. Since this angle is 180 minus A, I will have cos, open bracket, 180 degree minus A to be equals to cos. This is my opposite. So my adjacent is E, hypotenuse is B. So I have equals to E over what? B. But remember, cos cos 180 minus A, cos 180 degree minus A must be equals to minus cos A. Must be equal to minus cos A. Why? Cos is what? Negative in the what? Second quadrant. So if I have cos 180 minus A, it must be equal to minus cos A. And I'll replace my cos 180 minus A here. I'll replace my cos 180 minus A here with my minus cos A here. And this become minus cos A, which is this, will be equals to what? E over B. And if I make B subject of formula, I'll have E to be equals to minus B cos capital letter what? A. So I can clean some side now. But I don't need to clean what I'm proofing because it's a guide. So therefore, I'll put minus B cos A for what? E into, let's take this as equation 3. Let's take this as equation 3 into what? 3. So this is 3. So I have A square equals to B square plus C square plus 2EC to give me A square equals to what? B square plus C square plus 2. In place of E, I have minus B cos what? A in brackets, and I have my small letter C. So I have A square equals to B square plus C square. You can see that plus times, I can bring this minus out now. I have my plus minus 2. Let me put my B first. I bring my minus out, 2B, and I want to put my C cos capital letter what? A. Remember, these values are the distance. All these are the what? Distance, which is the side of the what? Angles. Why the capital letter A is the angle. So I have A square to be equals to B square plus what? C square. And you can see that plus times minus is what? Minus 2BC cos capital letter what? A. Please take notes. When you get here, don't stop here that there's a mistake here. Why? Because what this implies that if you have this, it's simply telling you that the angle is not obtuse, but what? Acute, meaning the angles are less than what? 90 degrees. But you can see that the angle B was said is obtuse, meaning this is greater than what? 90 degrees. You will now write, but angle A is greater than 90 what? Degree, being obtuse what? Angle. So therefore, since it's greater than 90 degrees, you agree with me that cos capital letter A is equals to minus cos open brackets 180 degree minus what? A. This is a theorem for the second what? Quadrant. Now, I have cos A to be equals to minus cos open bracket 180 minus A. So in place of this cos A, I can put what? This. So I therefore have A square equals to B square plus C square minus 2BC cos. Because my A now, my cos A equal minus cos. So in place of cos A, I will have my minus cos open bracket 180 degree minus what? A. Now this will give me A square to be equals to B square plus C square. Can bring this minus to this side, minus 2BC cos open bracket 180 degree minus what? A. This bracket, please. Now I will have A square equals to B square plus C square minus is plus 2BC cos open bracket 180 degree minus what? A. And with this, we have our angle, we have our theorem proved, which is A square equal B square plus C square plus 2BC cos capital letter 180 degree minus A to be equal to what? This. So this is how you prove it. And I want to draw your attention. Remember, that this formula is used whenever an angle that is greater than 90 degrees is given. It must be b square plus c square plus 2bc cos open bracket 180 minus a, meaning the angle given you must subtract 180 from the angle given, and this sign automatically what? Change. What you can also do, if you choose to use this, I'm not telling you to change because they said we should prove for this. If you are given an angle for cosine rule and is greater than 90 degree, and you want to use this very formula different from this top formula, then the angle must be you must subtract 180 from this angle given, which is greater than 90, and you must change this sign to give you what? Plus. Take note. So that's this. And at the same way, we can as well get that for b and c. Our b square now will be equals to what? A square plus c square plus 2ac cos capital letter what? Cos 180 degree minus capital letter what? B. And our c square also will be equal to, our c square also, small letter c square, which is side, will be equals to a square plus b square plus 2ab cos open bracket 180 degree minus angle what? C. For these two scenarios, just like the first scenario, our angle must be greater than 90 before we use this. If the angle is not greater than 90, then you use the first proof formula, which is a square equal b square plus c square minus what? 2bc cos capital letter what? A. Giving this shows that the angle is what? An acute angle. That's A is less than 90. But if A is greater than 90, you use either this or this or this. So that's it. We'll be doing some examples now to get you familiarized with what we're talking about. Thank you.